The goal of today's lesson is to solve exponential and logarithmic equations. How? In equations, we can undo exponents by taking the log or natural log of both sides. You can undo logarithms by taking each side and writing them as exponents, or we can use the loop method. Remember, for the loop method, the equation must be of the form log base b of y equals x, or b to the x equals y. Also, for log of x and the natural log of x must be greater than 0. Let's try some examples. Our first example is e raised to the x minus 2 equals 19. Because the natural log is base e, and because of the property log base b of b to the m equals m, we can take the natural log of both sides. This leaves us with the natural log of e to the x minus 2 equals the natural log of 19. Now we can bring our power down. So x minus 2 equals the natural log of 19. We can add 2 to each side, and we'll be left with x equals 4.944 after we put this in our calculator. Another way to do the same problem is by the loop method. With the loop method, we draw our loop and we'll be left with the natural log of 19 equals x minus 2. From here we can add 2 to each side, and again you can see we get the same answer as before, 4.944. Another example is 3 minus 5 times 2 raised to 3x equals 14. We can simplify this expression by subtracting 3 from each side, getting negative 5 times 2 raised to 3x equals negative 17. We can then divide by negative 5, and then we can take the log of each side. We can bring down the power, and then we'll be left with 3x times log of 2 equals log of 17 over 5. We can bring the power down due to the properties of logarithms we learned in a previous lesson. Then we divide by 3 log of 2, and we get our final answer, after you put this in the calculator, of x equals 0.589. Let's try another one. Now we have the log base 2 of x equals 4. We can use our loop method. We have 2 raised to the 4 equals x. 2 to the 4 is 16, so x is 16. Now let's look at the next one. 7 minus 3 log x equals negative 5. We can subtract 7 from each side. We'll be left with negative 3 log x equals negative 12. Dividing by negative 12, we have log x equals 4. Using our loop method, we get base 10 raised to the 4 equals x. And this gives us 10,000 equals x. For another example, we have the log of x plus the log of the quantity x plus 21 equals 2. For this one, we'll use our properties of logarithms to combine log of x and log of x plus 21 to get log of x times x plus 21 equals 2. Then we can use our loop method, so we'll have 10 raised to the 2 equals our x squared plus 21x. We square 10, and we're left with x squared plus 21x, move the 10 squared over, minus 100. Factoring this, we get x plus 25 and x minus 4. Then we can solve. We'll have x equals negative 25 and x equals 4. But there's something we need to remember. We know that we can only take the log of a number greater than 0. So here, x must be greater than 0 for this to be greater than 0, or x plus 21 must be greater than 0. So we have x is greater than 0 or x is greater than negative 21. So notice we have a number that is less than negative 21. So we're going to have to reject the x equals negative 25. Because you cannot take the log of a negative number. For our last example, we have log base 3 of x plus 4 minus log base 3 of x minus 5 equals 2. We can use our properties of logarithms to combine this log base 3 of x plus 4 minus log base 3 of x minus 5. The subtraction indicates division, so we'll have log base 3 of x plus 4 over x minus 5 equals 2. From here we can use our loop rule. 3 raised to the 2 equals x plus 4 over x minus 5. We can multiply each side by x minus 5. 3 squared is 9 times our x minus 5 equals x plus 4. We can further simplify by distributing the 9. 9x minus 45 equals x plus 4. Adding the 45 and subtracting an x, we have 8x equals 49. And we'd be left with x equals 6.125. So now, that is our final example. It's important to remember the beginning. How? In equations, how we can solve equations is undoing exponents, undoing logarithms, and the loop method. But it's important to remember, for the loop method, the equation must be of this form, and we cannot take the log of a negative or 0, so x must be greater than 0 for log of x and natural log of x. And that is it for this lesson.